Hello and welcome to VIA Tutor's SAT class. Today we are going to discuss the area and circumference of a circle. This is one of the 32 sections of the SAT math exam that you're going to need to cover. And the length of this lesson is going to be approximately 10 minutes long, including the time for you to try some practice problems. So we're going to begin by talking about the radius and diameter of a circle and define them. The radius, r, is the distance from the center to the edge of any circle. So here on the right side you see the radius r going from the center of the circle to the edge of the circle. And the diameter d is the distance from one edge of the circle to any other edge that goes through the center. So here you see the diameter of the circle. Now, one thing to keep in mind is that the radius is exactly half of the diameter. So if you take the diameter and you put it up there, you see that the diameter is twice the radius. So if you extend the radius all the way through, you end up with the diameter. So 2r is equal to d, and that's going to be important for our later equations. Now we're going to talk about arc length. Arc length is a tricky term, but it's important to keep that in mind. On the right side, you see a circle. And now we're going to take a chunk out of that circle by taking out a piece of the pie. Now, the distance from A to B on the edge of the circle forms the arc length C. So here, if you look on the right side, C appears. So what we put back in place is what we call the arc length. That's the distance on the circumference of the circle from the lines A to the line B. Another important term to remember is tangents. A tangent to a circle is the line that intersects the circle at exactly one point. So here on the right, you're going to see our circle again. And here is the tangent line going down, touching the circle. Line AD is tangent to the circle. And one thing that's important to keep in mind is that the angle formed by the tangent is always exactly 90 degrees. So now we're going to talk about the area of a circle itself. The formula for the area of a circle is pi r squared. Here we have our circle again. So if the radius of the circle is 3, then insert 3 for the radius in the formula. So we're going to replace r with 3. And then we're going to take our formula, and this is a given. Area equals pi r squared. This will be for all circles. This is always the equation for the area. Next we have pi times 3 squared, because we're replacing r with 3. And we square 3, so we have area is equal to 9 pi. And an important thing to remember is for the SAT, you can leave it in terms of pi. You don't need to calculate it out as 3.14. You can just leave it as 9 pi. So now we have the circumference of a circle. And here again we have our circle with a radius r. So the circumference, sometimes referred to as c, is the distance around the circle. The formula for the circumference is equal to pi times d, or c is equal to 2 pi r, because remember that d is equal to 2r. So if the radius of the circle is 4, then the circumference is calculated using a set formula. So we're going to replace r with 4. So if we determine the diameter, remember diameter is 2 times radius, so the diameter will be 8 in our equation. So circumference right away you know is equal to pi times 8, which is 8 pi. And simply using the radius, without trying to figure out the diameter first, all we do is we put in circumference is equal to 2 pi times 4, which is the radius, and circumference then is equal to 8 pi. Now we're going to do an SAT sample problem. Here, if the area of a circle is 25 pi, what is the radius? So here on the right we have our circle again. And we have our answers choices, 25, 5, 4, 16, and 6. So why don't you pause the recording now and go ahead and answer this and come right back and we'll solve this problem. Alright, so now we're going to solve this problem with a circumference with the circle and the radius r. So we have area is equal to pi r squared, and we're given that the area is equal to 25 pi. So 25 pi is equal to pi r squared. And this becomes simple algebra from this point on. You divide both sides by pi, so you have 25 is equal to r squared. And you have r is equal to 5. And that becomes the answer. Now remember that one of the solutions on there was 25. So if you forget to take the square root of both sides, you will end up with the wrong answer. So make sure to double check your algebra and make sure that all your equations balance out and you end up with the final answer. And the answer for this one is B. Now we're going to move on to sample problem number 2. In SAT sample problem number 2, we have a circle and we have a triangle inside the circle. And we're given that A is the center of the circle and B and C are points on the circle. If the area of this circle is 36 pi, what is the circumference of the circle? So why don't you take a second and see if you can solve that problem. Hit pause and come right back afterwards. Okay, now we're going to talk about the solution to this problem. So we have our circle and we have our triangle inside the circle. So we know that area is equal to pi r squared. That's a given. And we also know that 36 pi is the area. So we're going to say 36 pi is equal to pi r squared. Now, before we move on, let's just think about this problem for a second. The first thing we need to do is we need to find the radius given the area, and that's a simple equation. And then from the radius, then we can find the circumference. So 36 is equal to r squared by dividing pi from both sides. And then we take the square root, and we know r is equal to 6. So the radius of this circle, A to C, or A to B, both of them together, is equal to 6. So from there, we know the circumference is equal to 2 pi r. And so we have 2 pi times 6 is equal to the circumference. So the circumference is 12 pi. So the answer to this one is C, 12 pi. Now a few things to keep in mind. One, this problem contained a two-step solution. And this is going to be common for your SAT questions. It's not always going to be a straight find the radius of the circle or find the area of the circle given the radius. It's generally going to be a two-step process. So here we started out with area. We had to go down and find the radius, and then we used the radius to then find the circumference. Another interesting thing to point out is that on the right side in the circle, you see that there is a triangle and a 45-degree angle in that triangle. We never used that. So there will be miscellaneous information, extraneous information that's going to be put on the problem to try to trick you. So remember not to be tricked by that, and remember to make a plan on how to solve the problem like we did. We said we're going to go and find the radius, and then from there we're going to find the circumference, and then go ahead and solve the problem, and then disregard the extra information.